All right, thank you, Abbas and Molly and Oklahoma Geological Survey for this opportunity to present today about our project related to critical minerals in the coal strata of the Cherokee Forest City Basin. As Abbas said, my name is Franek Hasiuk, and I'm here to present on behalf of our motley crew of geological surveys and the Osage Minerals Council on this project that we currently have funded through the U.S. Department of Energy's CoreCM FOA. Just as a quick summary, so you know where I'm going with this presentation, our group is a mixture of 5 states and an Indian nation working together with both an industry and an Indian Nation advisory councils to target Pennsylvanian coals and their associated sedimentary strata for their critical mineral enrichment. We're testing multiple hypotheses for critical mineral enrichment by aggregating data across the basin to build both a new structural and stratigraphic model, which will then support more accurate critical mineral resource assessments by hanging that geochemical data on our stratigraphic information. And I apologize, it appears it's the day to mow the lawn outside my building. So if you hear any rumbling in the background, that's what that is. All right, so to take a step back, here in Kansas and our Cherokee Forest City Basin, we've actually had a group meeting for the last 45 years to discuss coal production and coal issues. Generally, it's gone by the name the Western Interior Coal Region Forum, but this group has had in-person meetings back when that was a thing, as well as field trips to visit various coal deposits and facilities that utilize coal resources. It's from this region that we built our team for this CoreCM project, which includes a group of folks here at the Kansas Geological Survey, as well as the Iowa Geological Survey and the Department of Geology there, Oklahoma Geological Survey, Missouri Geological Survey, the Nebraska Conservation and Survey Division, and the Osage Nation Mineral Council. And it's through this integrated team that we hope to produce the best quality understanding of critical mineral distribution within our basin. In addition, I said we have what's called an industry or technical advisory board. This includes members from both NioCorp, which is actively developing a critical mineral deposit in southeast Nebraska, the Phoenix Coal Company, which is an active coal miner within the basin, Martin Marietta, which is an active, the largest mining company in the basin. We have representatives from both the Iowa and the Kansas DOTs, which again are skilled at understanding what kind of rocks make the best types of roads. So they've got an intimate understanding of the rocks within this basin and how their properties vary spatially. We've got a member from the KU Innovation Park, because one of the deliverables from this project is to plan a critical minerals technical innovation center to commercialize and support tech transfer within the basin. And then finally, we have 2 experts, both emeritus in stratigraphic and geochemical aspects of our basin. So we like to think that we've got not just our own geological team, but we've got these folks that can really help us understand the mining aspects of what's going on with the basin. And then another aspect that we feel really acutely within our basin is that we have a number of Indian nations who aren't directly associated with this project, but will be forming a First Nations advisory council with members from these organizations that are interested in participating. We think this is a good thing, in addition to it being a requirement of the CoreCM project. So I think it's really important that we all remember when we're working on these projects, the environmental justice and social implications of what we're doing, and make sure that we're including as many stakeholders as want to be included in our projects. This project, as I said at the beginning, has been funded through the Department of Energy's CoreCM Initiative, FOA 2364. You can see on the right-hand side of my slide here a map showing the different CoreCM projects that are out there. We are the unfortunately colored brown one right here in the middle of the country. But as you can see, our project stretches across multiple states that gives us sort of a broad coalition of folks to work with. In terms of the basin itself, we have a legacy of coal mining and reclamation of coal mines. And we're also close to a lot of heavy manufacturing and industry. You may be aware of Kansas's aerospace industry, the oil and gas industry in Oklahoma and the Osage Nation. There's a lot of mining in Missouri. And then up in Iowa, it actually produces a lot of agricultural equipment. And so these different industries all have various needs for critical minerals, as well as serve as sources of critical minerals. And for this project, we'll be focusing on these coals within the basin, but also assaying various waste streams that occur within the basin. And my rightmost map here shows a variety of different waste streams that we envision assaying. We have our lead zinc tailing piles down in the tri-state area. We've got black circles that represent where our coal-fired power plants are within or near the basin. We've got cement plants as the green triangles, refineries are the red squares, and then also computers and electronics recycling centers. As we know, one of the end products for our critical minerals is in those types of devices. And so any recycling centers we have in our basin can also serve as sources of those critical minerals. So what really the centerpiece of our project is coming up with a new stratigraphic concept for the Cherokee Forest City Basin. Here's a paleogeographic map at about 315 million years ago. And we envision this basin as being something like a foreland basin system. And in a large part of this basin, we're dealing with the forebulge and backbulge setting. Excuse me. We're using that concept to recorrelate the stratigraphy within this basin, which has always been very complex to understand due to the cyclothemic nature of it. The multiple hypotheses that we have for critical mineral enrichment within our basin stem first from this Elk Creek deposit in southeast Nebraska. This is a known assayed critical mineral deposit currently under development by NioCorp. They describe it as a world-class deposit of niobium, rare earth elements, scandium, and titanium. And from what we understand, it was exposed during the life of this Cherokee Forest City Basin. So erosional products from that deposit may have been distributed more broadly within the basin. So one thing we want to do is track critical mineral enrichment as a function of distance away from this deposit. In addition, we have another working hypothesis that critical minerals may have been enriched through the upwelling of anoxic bottom waters coming up into the basin during times of black shale deposition. And in addition, there always could be something else that's driving our critical mineral enrichments throughout the basin. So we want to make sure that we're not too dogmatic in pursuing our tests of these first hypotheses and be open to other explanations that arise as we analyze our data. Again, I like to go back to this quote from one of our greatest explorationists. Wallace Pratt said, "Oil is first found in the mind." And so when we think about critical minerals, I think we can think about them the same way, is that we got to think about where we might find them, not just go out and blindly survey the surface of the earth. And so a little bit more about this Elk Creek deposit. It's a carbonatite. If you're not familiar with carbonatites, there's a modern carbonatite you can go visit in the East African Rift, where it's erupting carbonatitic lavas today. It's a rather surreal scene to see lavas that aren't dark in composition like this. Essentially, our first hypothesis, as I said, was the weathering of this Elk Creek deposit, enriched coals that were being deposited in adjacent shallow marine basins. Our second hypothesis is upwelling could have enriched our black shales, both in critical minerals from deeper within the Cherokee Forest City Basin, as well as erosional products from the Elk Creek deposit. Now, as I said earlier, the rather complex stratigraphy that we see within the basin is formed by rapid sea level change during the Pennsylvanian, producing what are generally called cyclothemic deposits, where we have very thin beds very rapid changes vertically in our sedimentary character, such that we have multiple coals, multiple black shales, and multiple intervening beds. From this, we're taking our exploration approach is to focus on the coals and the underclays under the coals, looking in those coals for erosion products from that Elk Creek deposit, looking in the underclays for things like lithium, rare earth elements, and possibly aluminum. These underclays were actually prospected during World War II as a domestic source of aluminum for the aerospace industry, which is just down the road from Lawrence here in Wichita. But in addition, look at the black shales, which have been shown to be enriched in a variety of other critical minerals. One of the other benefits of this type of rapid facies change, because we always got to look for the benefits in the stratigraphy that we're given, is that there are other materials that can be used in the processing of these types of deposits. It's not just one giant deposit of something. We've got some limestone stratigraphically nearby in any deposit that you might be producing. We've got clays that have been used in the past for cement production. And so in addition to the economic development that can come from critical minerals development, there can be economic development from, for example, finding really high quality road building materials or high quality materials for the cement industry. So just walking through a little expose on each of our states here and each of our coal mining traditions. So Iowa has a long coal mining history that ended around the turn of the last century. Estimated total reserves of 7.5 billion tons, some estimates up to 30 billion tons. These 48% of these have been classified as measured deposits, which indicate seams over 14 inches thick. You can see in the map that they spread across a broad outcrop belt from central Iowa down to southeast Iowa. Less than 10% of these reserves have been removed. And we can see a charming picture here from the life of coal miners back then, which can remind us today also that we want to try to develop these mines in a way that provides good, safe jobs for the people working in them. Here in Kansas, we've had 160 years of coal production amounting to about 300 million tons. Our coal deposits are limited, or our outcropping coals are limited to the far southeast part of the state, but in the subsurface, these deposits actually provide a lot of coal bed methane, and in some cases have bonus critical minerals like helium in them. And so these are other sorts of, again, materials that can be produced as part of a holistic critical mineral production program. In Missouri, we have a map here showing the distribution of surface coal mines, both past and present. Currently, there's a continental coal mine that's just about to start operations again if it hasn't started already. In Nebraska, probably the least well endowed in terms of coal, but they make up for it with the Elk Creek deposit in terms of critical mineral abundance. The only comprehensive study of these coals was done in 1977, and they're all known to be subbituminous and bituminous, outcropping in only 5 counties in far southeastern Nebraska. One commercial mine existed for a time in the early 20th century, exploiting a 1 meter thick seam in Nemaha County. All other coals are known to be pretty thin, on the order of 1/3 of a meter or a foot thick. However, 7 other thin coals have been identified elsewhere in the Pennsylvanian stratigraphy of Nebraska. Oklahoma, we heard about Oklahoma yesterday. So this is largely a summary or just a snapshot of what Abbas was able to show us. The Oklahoma group is looking at both commercial and non-commercial deposits that are existing within their jurisdiction. Also looking at sampling fly ash deposits using a push core tool. And Oklahoma will be doing electron microprobe analysis also to verify the micro locations and mineral hosts of our critical minerals following the approach of Yang et al. 2020. We're also happy to have the Osage Nation as a part of our project team. A little background, they ceded over 100 million acres of land to the United States in the 19th century, but then turned around and bought their own reservation, which they paid for the original survey. Originally, this was land that nobody else wanted, but this allowed them to keep their minerals intact. And they've produced over 1.3 billion barrels of oil, along with 12 other types of income derived from mineral sources. Current production is over 11,000 barrels of oil per day, estimated 13 billion barrels left. And you can see a pool map here down in the corner showing on their lands the quite extensive distribution of oil and gas pools that they have. The Osage Nation Minerals Council was created by the nation to administer and develop the mineral estate and looks to maximize tribal resource exploration and development. All right, so the tasks for this project, like in any task from the DOE, you've got a list of tasks. The first is to deliver the project on time, on budget, and safely. And this task includes environmental and social justice assessments. The second part is sort of the meat and potatoes of the geology of the project, and I'll talk a little bit more about this in detail in the coming slides. But then I wanted to make sure that folks were aware of all these other plans and assessments that are required by these CoreCM projects. These aren't just geology projects. These are sort of integrated geology, mining, engineering, business, and social projects. And so we have a lot of different moving parts that are meant to identify waste streams that are within the basin, identify infrastructure needs, industries, and business needs for critical minerals within the basin, identify the different technologies that are needed for assessing, developing, and testing critical mineral use within the basin. Again, I talked briefly earlier about the Technology Innovation Center, which is meant to be a central location within the basin that can serve as a commercialization engine for critical mineral technologies, as well as a place for tech transfer to occur from research projects out into active industrial and business use. Finally, we need a strong stakeholder outreach and education plan to make sure that everyone within the basin understands what critical minerals development means, both to their community, to their government organization, to their industry, to their specific business, to their pocketbook. Are they going to, how is critical minerals development going to affect mineral rights that people have? Are they going to make them more valuable? Are they going to change that value? All right, so just a chat here on each of our major subtasks in data aggregation, because from what I've seen so far, I think we've got a lot of geologists here who might be most interested in some of these geological things that we're working on. So the first big step is data aggregation. So we're aggregating both well and outcrop data from across the various jurisdictions into one uniform database so that we can model the stratigraphy within the basin more accurately than it's ever been done before. Our sources of data include the USGS, EPA, state geological surveys, tribal mineral councils, as well as state and tribal regulatory data. So from folks like here in Kansas, the Kansas Corporation Commission has a lot of information about stratigraphy within the state and production from those strata. Once that's all together, we'll be producing regional integrated stratigraphic surfaces for the Pennsylvanian age deposits within the basin. And we're going to do that through the application of our hypotheses about this basin being a forebulge, backbulge setting during deposition. We're going to use those surfaces to build 3D models of stratigraphic intervals so that we can then hang our geochemical data on that and identify sweet spots and fairways of critical mineral accumulation. This will serve as our fundamental hypothesis that we're going to test with drilling during a phase 2, should we be so fortunate to be supported in a phase 2 project. Oh, there's my arrow. Subtask 2.3 are the actual resource assessments. This is where we're going to be doing chemical and geochemical analysis on a variety of different materials, both the geologic materials like coal and associated strata, but also combustion byproducts, refuse, acid mine drainage, and other basin-specific resources that here would include things like helium, coal bed methane, low alumina limestone, as well as water resources. Our technical approach again here is correlation of the strata basin-wide using well logs, cores, and outcrop descriptions. We're going to be incorporating legacy geochemical data, but also acquiring novel geochemical data. 3 of our surveys have portable XRF units. The University of Iowa will be performing ICP-MS analyses. Oklahoma Geological Survey has electron microprobe that's going to help us understand our host mineral phases. And then we'll be doing geochemical well logging at select wells, which I'll talk about here. This is one technology we're really excited to test as part of our project. So recent advances in geochemical well loggings allow us to derive elemental contributions contained with gamma ray energy spectra. These can work in both open and cased hole environments and allow us quantitative measurements of both non-critical and critical minerals. These elemental concentrations can be applied to our stratigraphic correlations, as well as calibrated with our, we can calibrate these logs with analyses on core material from the same wells. And this log is really exciting because one critical mineral, gadolinium, provides one of the strongest signals that we can have in a downhole environment from this, this logging tool. And we hope that that'll serve as a proxy for other critical mineral abundances. So again, it's going to be important for us to be able to calibrate that signal with lab-based measurements. In addition, KGS was just awarded through an EPSCoR partnership the ability to purchase a geotech core scanner, which will be arriving next year. That's going to allow us to perform these sorts of analyses on cores, which may not have well logs associated with them. So in summary here, I'm going to again remind you that this is a 5-state and Indian Nation group working together with both industry and Indian Nation advisory councils. We're targeting Pennsylvanian coals and the associated sedimentary strata and testing multiple hypotheses for critical mineral enrichment across the basin. We're aggregating data across the basin to build new stratigraphic and structural models and performing our critical mineral resource assessments across the basin by hanging that geochemical data on our new basin model. And just in final closing here, I'd like to say that this is all of these critical mineral projects are going to be difficult, right? This is not easy stuff. The geology is hard enough, but the social, economic, and political side of these critical mineral projects is probably going to be even harder because it's something that us scientists maybe aren't as used to dealing with, but 2, involves a lot of competing interests. And so I think that this is like I said, this is going to be a complex project to execute. I think all of our projects are going to be complex to execute, and we should really remember the broad community within which we are acting as geologists and resource producers so that we can make sure that we are doing this in the right way, right? Here in Kansas, Oklahoma, Missouri, we have a legacy at the tri-state area of waste piles from mining, and we don't want that to happen again. I don't think anyone does. Ultimately, those piles may yet serve as sources of critical minerals that we can go after in a relatively easy manner, but it's something that we need to be able to communicate effectively, both the certainties and the uncertainties that are associated with these types of not just geology projects, but really industrial, social, political, community projects, and make sure that everything is working together. We can't neglect any part of these projects. So with that, I'll say thank you for your attention, and I'll take any questions you might have.